everyone. In this short video, I am going to show you how to find the R value and line of best fit for a set of data on the GeoGebra website. Once you have those, I'm going to explain how to interpret them. So how to identify what the R value and line of best fit is telling us about the data. And finally, I will explain how to use the line of best fit to make predictions about the data. We will be using this example. This example says, a group of children go to an after-school program at a local youth club. The director of the program keeps a record, shown to the right, of the time in minutes each student spends playing video games and doing homework. So notice the column on the left represents amount of time spent playing video games, such as 40 minutes, 70 minutes, 60 minutes. And the column on the right shows amount of time spent doing homework, such as 10 minutes, 30 minutes, 50 minutes. Let's first find the R value, which is called the correlation coefficient. And then we will explain what the correlation coefficient suggests in the context of this problem. The first thing you'll want to do is copy your data. So you'll notice I now have my PowerPoint in editing mode so that I can copy these values. Now I'm going to go to geogebra.org. I will click on GeoGebra Classic, then Spreadsheet. I will click on the first cell and click Paste. Then I will highlight my data, click on the button that looks like a histogram, and click on two variable regression analysis because we're comparing two variables here, amount of time spent on games and amount of time spent on homework. Once you click that option, you'll see a scatter plot. To find the R value, you're going to click this button called Show Statistics, and the R value shows up here labeled R, negative 0.7655. So here's our R value, and remember, an R value identifies there is a strong relationship between the variables if it is either close to +1 or close to -1. If it's close to +1, that symbolizes a positive correlation. -1 symbolizes a negative correlation. So in this case, our R value is pretty close to -1, meaning there is a strong negative correlation between these variables. We can go even further by explaining what we mean by that. Remember, in a negative correlation, as one variable increases, the other variable decreases. Meaning in this scenario, as the time spent on video games increases, the time spent on homework decreases. We're now going to determine the equation that represents the line of best fit for this set of data. Then we're going to explain what the rate of change represents in the context of the situation and explain what the y-intercept represents in the context of the situation. This is the same page I had opened before. I have here my data, I have my scatter plot. To find the line of best fit, you're going to go to the bottom of the page where it says regression model, click on linear. It will draw the line of best fit on the scatter plot, and it will also show you the equation at the bottom. So the equation is y equals negative 0.553x plus 61.3098. So here's the equation for our line of best fit. And by looking at the equation and referring back to my knowledge on linear equations, I can see that the rate of change is negative 0.553. Now, remember what rate of change means. It basically represents the change in y every time x is increasing by 1 unit. So we connect that to this situation. And we can say, for every additional minute that a child plays games, his or her time spent on homework decreases by 0.55 minutes. Because remember, in this situation, X was represented by time spent on games, Y was represented by time spent on homework. I look at the equation to identify the y-intercept. I see it is 61.3098. I think back to what y-intercept means. It is the y value when x is 0. So I connect that to this situation. Again, remember x is games, y is homework. So a child that spends 0 minutes on games will spend approximately 61 minutes on homework. Finally, we will predict the amount of time that is spent on homework by a child who spends 65 minutes on playing games. And then we will round to the nearest whole number. This is a common use for regression equations to help us make predictions about the data, since it gives us an overall representation of the data. So we will use our regression equation and simply plug into it. We want to make a prediction regarding a child who spends 65 minutes on games. Remember, games is represented as the x variable, so we will plug 65 into x, then simply calculate. Our result is 25.3648. So we can predict that a child who spends 65 minutes on playing games will spend 25 minutes on homework. Of course, this might not be the case for every single child. This is simply a prediction that we can make based on patterns we've noticed across the data. You can also calculate predictions using GeoGebra. It's actually faster this way. You can simply go to the bottom and enter your x value. Remember, our x value was 65. GeoGebra will show you the associated y value. Lastly, I want to reiterate that it is much easier to copy and paste your data rather than entering every value manually one by one. And you should be able to copy and paste the data that's provided in the MyOpenMath questions. For example, this is a question in MyOpenMath. I can easily highlight, click copy, then go to GeoGebra, click on the first cell, and then click paste, and notice the data has been fully pasted.